So we are going to do netting. We will do all three nets: static net, dynamic net, and dynamic net overload. For static net, the example that we are taking is traffic from 10.0.0.3 need to get translated to this address. This address need not to be there on the interface. It can be any address which is on the WAN side. Look at this, on the WAN side you got 20 network. So the mapped address also need to be in 20. The host portion should be unique. So we give 5.5. Let's see how to do this NAT. Before NATing, if I try pinging, the ping won't happen. For example, I'll go to 10.0.0.3 PC and try pinging 2.2.2.2, which is behind the internet router. Ping don't happen. The reason is the public IP address is what needed for this traffic to ping. When I ping, the packet is sourced from 10.0.0.3, which is an unreachable address for router 2. Router 2 is like an internet router for us. When you check router 2, you'll see packets coming in. But when it tries to return back, reply back, respond back, packet get dropped because of unroutable. Debug IP packets. I'll go and ping once again to show you this. As this ICMP packet goes there, look at this. The packet is coming from the source 10.0.0.3, and when the destination response tries to go out to the original source, it says unroutable. And the response packet, this is the response packet. All right, now what is next? If we change the source address, which is we called as netting, source address we change, we translate, then this ping can be possible. Let me do that. Our command is this IPNet source inside. Sorry, before that I want to say we need to define the inside and outside. For us, F01, F00 is the inside, interface F00, IPNet inside, and interface G3/0 will be the IPNet outside. This is a common configuration that needs to go before you configure NATing for all these three NATs that you're going to do. So I'll not be repeating this command again because it is same for dynamic NAT and dynamic NAT overloading, which is also called as patting.
So you can also write the command inside and outside when you give an IP address at the interface?
Nothing wrong in it.
Can we?
Nothing wrong in it.
Okay.
IPNet inside source is static. So when I say inside, it understands that from inside there is something going to come. And who is the source? I said I want to give statically, which is 10.0.0.3. And what's the mapped address that you want to do? You can use interface 10.20.0.0.1 by saying interface G3/0. But in our case, I want to give a dedicated address. So I say 20.0.0.5. And that's it. Nothing more is needed. When you try typing show IP NAT translation and see the verification of this, even before the NAT translation happens, you can see here the The configuration that we have made here, reflecting. Only for the static NAT you will see this. For the dynamic NAT, only when traffic is generated and translation is initiated, you will see an output. Now we are in static NAT, so let's focus on this. When I go and ping now, the ping should happen. The ping is going to happen. Let me go to the second PC and see from where the traffics are coming. Even now the traffics are coming from 10003, which means translation did not happen. But there's some problem with the configuration.
Sir, is there a route like IP route, the static route on R1?
There is before earlier when we were pinging it, the packet was going. Yeah, the packet is going. This is not a routing issue on R1. This is not a routing issue on R1. I just want to check the NAT statement. Oh no. You know what? I did all the NAT configuration on router 2. It was a wrong router. It was a wrong router. Show IP NAT translation. This should have been done on router 1. I cancel this. Very bad. Interface G is 0/3. I should cancel all those things. It was wrong router I was configuring. You understand what has happened?
Yes, sir.
Alright, so those configurations should go on R1. I'll go back to R1. Interface F00, IP NAT inside. Interface G3/0, IP NAT outside. Now, let's write the NAT statement. IP NAT inside the source is static. The address would be 10003. Translated 20005. Show IP NAT translation. Right now, the expected result will come. The ping is going to happen. It is. Now let us go back to router 2 and see from where the traffics are coming now. It is coming from 20005, which is this mapped address, which is the NAT address. To that address only the responses are given. So when the packet is received on 20005, the reverse that happens when the packet gets delivered to 10003. As a result, you see the replies here. This is a bidirectional NAT. Even from outside, if you try pinging, the ping will happen, which is not possible on other NAT. You see, I can ping from here 20005. And who will be responding me? 10003 is responding me, which is not possible in dynamic NAT. The reason is, in dynamic NAT, the mapped address can be given to anyone. It's not binded statically. Okay, now let's do dynamic NAT.
Sir, just one question. If you're not paying, if PC1 wants to ping R2 G3/0 interface, do you need the IP route command on R1?
Why you need? You no need, because they are directly connected.
No need, right?
Mm-hmm.
Okay. Thank you, sir.
You're welcome. So I remove the static NAT and let me put the dynamic NAT now. Dynamic NAT, if it is more than one inside computer, need to get mapped. Then if inside computer is 100 computers, then you need 100 IP address in the pool. Practically not possible. Otherwise, there will be a wait time. There will be slow in communication. For example, if I have only one IP address in the pool and I got two PCs to ping, they will ping, no doubt. Both will use the same address and ping. But both cannot use the same address at the same time. When the first PC session gets over, then only the second PC can use. First PC send one packet and get response. In the gap, second PC will also send one packet and get response. And the third, and again, first PC sends the second packet. There will be some sort of conflict in using the mapped address. You may not be seeing it. It's not a it's a seamless one. But if you will have some telemeter or something like that to measure the time taken, compared to the next one that we are going to do, dynamic NAT overloading, this is going to be slower. The reason is one address need to be shared with many inside, which is also there on the next method, dynamic NAT overloading, but here there is no port number involved, so there is going to be delay. Only when one finish using the address the other can use. For that you need to create a pool. I'm going to create a pool with these two address, IP NAT pool. I'll give a name NAT underscore pool, some name. Starting address will be 20003. The ending address will be 20004. Net mask is 255. And secondly, you need to write an access list to say which all computers can get NATed, which all IP address can get NATed. So I say access list 10 permit 10001, sorry, host access list 10 permit host 10002. Next, I need to attach this both in a statement. IP NAT inside, packet is coming from inside, but the source is not static. The source is dynamic. Anyone from this list 10. List 10. That source can be this guy or this guy. IPNAT inside source list 10. Should use the pool NAT underscore pool. That's it. So this is what we call it as dynamic NAT. So anyone from this access list 10 can go and use any address in that pool, any available address. As a result, if you see, when I ping from the first computer, the address used for mapping is different from the IP address that the second computer, when it pings. Now let us go and verify this on R1. Show IP NAT translation. You can see when traffic is coming from 10.1, it got translated to the first address in the pool. When traffic is coming from 10.2, it took different address, not the same address. To differentiate, this is not using the port number. You see, the port number is not the same. And it could have used the port number, but this is not using because it's not PAT. It's simply dynamic NAT port. It is simply dynamic NAT. But the delay will be a problem if there is too many computers and two addresses in the pool. We got just two addresses in the pool and we got 2,000 computers inside. Then definitely there will be a delay. Easy to identify the delay. To avoid that, what we need to do is we need to simply add one keyword. One keyword overload. Now show IP NAT translation. You see there is no translation. Now let us ping. I'm pinging from first computer. I'm also pinging from the second computer. That mapped address will be the same. You see, when traffic was coming from 10.1, it took this address. When traffic is coming from 10.2, it took the same address. And what makes the difference is when traffic is delivered to this 195.22, it will be sent to 195.22.20.004. If traffic is delivered to 184.98, it will be delivered to 189. Sorry, when traffic is delivered to 184.98 of this public address, it will be translated to 10.00 of the same port number. Port number is involved to differentiate the destination to which the packet needs to get delivered. Any question?
No, sir.